So here we go. Trying to learn game development. Shit. So where is my guy? This is the man. Oh, this is the one. God, I guess. Let's see. I will follow him all along the videos. I hope you guys also know him. If you don't know him, he's a Prekais. I don't know if I pronounce it right. Maybe Prekais. I don't know. Guys, I'm watching him since 6 years. Yeah, like I'm not actually watching him. When I was 6 years ago, I used to watch his videos a bit, and I got inspiration of making games and something like that. So after a while, I saw his games and I saw his videos. Then after 2 years of watching him, no, after 2 years not watching him obviously, I was just watching his some videos. Like I got interest, and he uploaded this video. Goodbye. Then after that, I thought he's done for. Like not done for. Actually, I done with YouTube. And I saw this video, and I thought he's okay with that. Okay with YouTube. He could with YouTube. So I didn't had that much interest also. But after some time, I saw this video. And after he got this video, I was very excited that my inspiration is back, and I can start all over again. Not actually all over, but I can finally start to learn. I got a little motivation, something like that. So, as to make motivation discipline, I made this YouTube channel. I didn't make this channel just to like upload videos or do a live stream. I just make it to be consistent on the project what I am making. But let's see how it will went. So this is the video that inspires me. Then he started making these videos. He started making videos on Godot. I guess I pronounced it right. Then I will not watch these videos. I will watch this playlist. This is the
If you want to make
playlist.
a video,
This is the playlist I will follow. And I guess I will learn. This is the first time me making games. That time, 6 years ago, I only watched his one or two videos, and I got like, as you like, where's my channel? Let me tell you something. This is the channel I have. This is my live stream I'm doing right now. If I close this, and will I go to on my description? You should read this thing. Okay, yeah, you will read this. And I got an inspiration of making games and getting in technology field when I was a kid, and I used to think how the game is made and how I can make it. Someone on earth made that, and I got these thoughts when I was 10. Then I started thinking about all of that. Then I started researching. I didn't had anything, any gadgets on any mobile or phone, anything like that. So I had my mom's phone, something like that. So I got everything started from there. I researched a bit. I got the knowledge of doing everything. So I wished that time, but I didn't had any devices and any equipment that time, so I can make it on. And some people will give excuses that you don't need any devices or you don't need anything. Just start with what you have, buddy. You can't make a game with a smartphone. So yeah. So from now on, I got from now I'm like 20 right now. So now I got the things that I want. I have a pretty good laptop. I got RTX 4060, freaking very good GPU. And then I got everything that I need. I have a good phone, I have a good laptop, I got internet connection, and I have a little bit of time. That's the thing. When we were a child, we had the time, but we had the gadgets. But when we grow up, we had the gadgets, but we didn't have time. So we still have to manage. But let's see what we will do. At a little bit of time, I will give my some time to my dream, and I will keep working on my dream as a game developer. And Yeah, from now I will start it, I guess. So now I have to tell you that I have zero, freaking zero knowledge about game development. So don't judge me. I will starting from the scratch, like very, very, very scratch. So I will see what I will have to do.
Video game but don't know where to start, this video should help point you in the right direction. Making games is a complicated subject, but let's try and break it down. When the big studios create games, they do so in large teams. Each person has a specific role, whether that be 3D modeling, programming, doing concept art, or sound design. In reality though, most people don't start with a team of professionals, more just a single laptop
As I am doing
and some good ideas. That's at least how I got into it. Luckily, over the last few years there's been a big boom in the indie games industry. Now
the game. What the heck is that? Bro, I'm not a robot, obviously. Oh, okay. So, as I can count myself as an indie game.
smaller teams or even individuals can make hugely popular games such as Superhot or Undertale, just to name a few. Every video game runs on what is called a game engine. The engine is what tells the components in the computer stuff like how to render graphics or play audio. Games such as Half-Life 2, Counter-Strike and Portal all run on the source engine, which is also why they have so many things in common when it comes to physics, graphics quality and gameplay. Previously, game studios would have to spend a huge amount of work creating an engine from scratch or purchase a pre-existing one from another studio, which was not cheap. But these days, a lot of independent engines have been made with the sole purpose of people using them to build their games on top. This brings us to the first decision an aspiring game developer has to make. What engine should I choose? And the answer is, well, it depends. There are a lot of engines to choose from, and they each have their strengths and weaknesses, but here are some of the most popular ones. If you're interested in making a 2D game and want to start with something not too difficult, I find that GameMaker is pretty easy to pick up. Some examples of games made using GameMaker are Spelunky, Undertale, and Ink. GameMaker is essentially free, however some features do require you to purchase a license. I don't find most of these too important for beginners, but do note that you can only export to Windows using the free version. Unity, however, allows you to build games in both 2D and 3D that can be exported to a variety of platforms. Being currently the biggest player when it comes to indie development, Unity has powered games such as Hearthstone, Superhot, and Kerbal Space Program. Unity is also used by a lot of mobile developers. Unreal Engine is probably the most advanced of the three. It's an amazing engine for more experienced developers who are looking to make 3D games, but I wouldn't recommend it as a starting point. It's known for powering some really heavy games like Unreal Tournament, Gears of War, and Arkham Knight. Now some of you might know that I'm a bit biased here. After all, my entire YouTube channel is built around Unity, but I do believe that Unity is the perfect starting point for most developers. This is not because it does everything perfectly, no engine does, but because of its diversity. Unity supports both 2D and 3D games and deploys to both the web, desktop, mobile and console. Also, when programming in Unity, you can choose between C# and JavaScript, two widely adopted programming languages. So what you learn in Unity can easily be applied to other environments later down the road. That's why I've decided to make a short series on how you can make your first game in Unity. The videos aim to teach a bit about everything, so that no matter if you want to become an artist, a level designer or a programmer, you will hopefully find it useful. So click on the screen now to be taken to the first video once it's out, and that's pretty much it for this video. If you liked it, consider subscribing. Also, if you want to see more videos like this one, you can support me over at Patreon.
Okay, we so got the knowledge. Let's see.
So here's a step-by-step guide on getting started.
So here we go. This is the first episode and the first video. We're gonna make it on Unity, and hopefully I have Unity. I downloaded it before because I knew I will need Unity, and I got some research, did some research, and yeah, we gotta use Unity. And here we go.
With your first video game. What you see on the screen now is what we're going to be making through this mini-series. It's really simple and arcadey, but it's always easy to add more gameplay elements and cooler graphics at a later point. Right now, let's just jump into it. So let's begin by installing Unity. If you've already done so, you can just skip ahead in the video. First, we need to go to all of these rates. First, hit this is artist. Then you go you can just hit new to as one that added. You can use it. Use Unity. Now let's just keep it at 3D. Let's pick a location.
I have Unity. If you guys know and you want to download, you can just watch this video that I'm watching right now, Break Eyes with you, and then you can download it.
For our project. and hit create. So here's what Unity looks like right when you open it up. You'll notice that I have a dark skin for Unity. That's because I'm using a paid version. But other than the color of the editor, that's not going to make any difference throughout these videos. So let's begin by exploring the user interface. So in the middle here we have this scene view. You can use the mouse wheel to zoom in and out. You can use the middle mouse button to pan around.
Yeah, so let's open Unity first.
Let's give it much definition. I have not going to make any difference throughout these videos. So let's begin by exploring the user interface.
So first I tried something, but this is nothing, just a random thing. And here you go, from the scratch, Universal 3D, and art. This is it, I guess. This is the thing I have to select. I had no idea what the heck is this. This. I guess I will start this. Never mind, let's see. Because this guy, Prekka, is using. I'm watching 7 years old videos, but I guess he's the best. So maybe why? Who cares about it? 7 year olds or five or one or who cares? Just okay. Never mind. It's downloading. Okay, till then I will watch the video.
So in the middle here we have this scene view. You can use the mouse wheel to zoom in and out. You can use the middle mouse button to pan around. And if we hold down Alt and left click, we can then pivot around the center of our view. Over
Go download it fast. Yeah.
here we have the hierarchy. This displays all of the different game objects that we have in our scene. You can see here our scene is currently untitled and it has two game objects, the main camera and the directional light. Notice that when I click on an object, say the main camera, the inspector will display properties for that object. Each one of these collapsible things here are called components. Components are what makes objects do different things, but we'll get into that in a second. We also have the project panel down here, which shows all of our different game assets that we can then drag into our scene, making them appear in the hierarchy. You can totally rearrange Unity in any way that you would like and drag around panels and really go crazy with this, but remember you can always go to the top right corner and select default, and it's going to reopen to the default layout. And any window you don't already have open, you can go to window and select it from here. So let's start building our game. First off, we want
The whole thing, and I guess I already say I'll just shrink it a bit. No, I guess how can I remove this it with this? Can't remove, I guess. It is. Maybe I didn't select anything different. This is very different from his perspective. Can I remove this? His perspective. It's a console project and inspector. Yeah, this is it. Wow. Inspector here. Okay, remove reading asset. Removed it. Importing assets. What the heck?
want to create a
Okay, so what did he say? I can move around with this. I can grab with the middle mouse button, and then I can use Alt to move around the object. Okay, this is my camera. Okay, so this is the light, this is the camera, and this is my object.
ground plane for a player to stand on. To do that, let's go over to the hierarchy, right click, you can also go under create and select 3D object cube. This spawns a new cube.
Okay, so redo, right click. What?
Right click, you can also go under create and select
Bro, it's freaking says changed here. 3D objects, cube, and I have a cube here. Yay, I have a cube. I can look around it. Now, buddy.
select 3D object cube. This spawns a new cube into our scene. Again, we can use the movement controls to have a look at it, and we can always quickly focus on it by hovering over the scene view, selecting it, and hitting F. Now the cube currently
F. Okay, nice. This is good. There is the light. If that's the sun, what the fuck is that? This is turns the camera. What the heck is this thing? Never mind, who cares? If
is somewhere in our scene, and it's really hard to get a look at where. So what we'll do is just go over to the transform here, right click and hit reset. And that just centers it. You can see the position.
okay, right click, reset. Got the movements. Okay, so he caught inside the object, or maybe object caught inside it. These are hard, bro. I'm supposed to move it. Okay.
Is now 0 on the X, 0 on the Y, and 0 on the Z, and gives it a scale of 1 by 1 by 1. Again, hit F to focus on it. So if we go into our game view, we can now see our cube through our camera. If we want, we can
Okay, I got you. Oh, I can see it through my camera. Scene. Here's the camera.
take our game view here and dock it to the right so that we
Good, very good.
can see both our scene and the game view at the same time. Then we can take our camera here and we can readjust its position, and you can see
We can readjust the camera's position. So this is z-axis, the red one is x-axis, and the green one is y-axis. Okay, got it.
see that updating in real time. I'm just going to press Ctrl Z to undo that. I'm then going to select the cube and scale it up. Let's give it a scale of 15 on the X. We keep it at 1 on the Y and give it, say, 100 on the Z. If we zoom out now, we can see just how huge this ground plane is.
Okay, so I will give cube at 10. Yeah. 0, 0. Yay, I got a really huge surface. Mhm. F. Where the heck is my camera? Main camera. Just got a little up. Okay. The surface.
Is. We can then go and rename it to ground. And
Oh, okay. Ground. Ground. Ground.
we can simply drag on the blue arrow here to move it over. Something like that. Just so it starts.
Good idea. Is it even moving? Yeah, it is. Okay.
About at the same point as our camera. Then let's create another object. So right click, go 3D object and then cube. Again,
Create 3D object cube.
let's reset the transform so it's centered on our scene. We can then drag on this green arrow to move it up. Let's
Cube, it's already reset, and then I can do this. Hey, okay, can I do this reset? So I guess this is the platform and it's the running. Yes, this is the perfect angle.
again hit F to focus on it. And we can see that we now have our new cube here standing on the ground.
For the new cube standing on the ground. I wanna change the freaking color. I don't like this color. We're gonna change it. We're gonna change it, bro. Oh, material, was additional setting, box collider, material, box collider. Oh, I can't change it. Anything is on material, let, lightning. Never mind. Let's just make it. I don't know anything. So I don't want to mess up. I don't want to mess up.
This cube is going to be our player, so let's go ahead and rename him to player. And let's also make him a bit more visible, because right now everything is pretty boring white. To do that, we need to assign a material to our player. And we
He just taught us how to change the color and the material. I was doing freaking thing and doing it all myself.
create a new material in the project panel. So let's right
Make a new material.
click down here, go create, and then material. We'll name
No. First of all, player. Why the fuck I have so many things here?
this material our player, and then mat.
I don't have anything. I have so many things here. Why? Okay. I have no idea. I'll just create.
Format create, and then material. We'll name this material our player, and then mat for material, but that's optional. Let's hit enter. Now we can adjust different properties on this material. Stuff like how metallic it should be, the smoothness of the material, and the color up here. So we'll make this some kind of bright red. And what we can do is then simply drag our player mat onto our cube. And you can see
Oh, so what I have to do? I will make a material for anything. I can just metallic. Oh, wow. But I will make another one. Material. It's
it updating in real time. So simply let go and it's applied. And any changes that we now make to this material are going to update for our player. I think our camera
brown.
is a bit far away, so let's also select our camera and move it a bit closer. Again, we can move it over by simply dragging on this arrow, move it up a little bit, and that looks a lot better. So now if we were to hit play and actually
So make it closer. Here, not too much. It's fine. Yeah, and then I will play. Can't do anything. Yes, obviously I can't do anything. I didn't
run
do
our
anything.
game, not much happens. That's mostly because we haven't done any programming yet, and so we can't really control the player, but we also need to add some physics into our game. Right now, if we exit play mode, take our player, drag him up here, and hit play again, he's just going to float in the air. He's not falling down. The reason why is that we need to tell this game object to interact with the Unity physics system. To do that, we go out of play mode and add a new component. In our case, we want to add the physics rigid body component. Now when we hit play, we should see that our cube falls to the ground, and it
Okay, so here you go. Here you go. And then I will add component. What was that? Rigid body. Wow, sexy. Oh wait, it wiggles.
indeed it does. Right now it falls in a bit boring way, so let's try and rotate our cube a bit to make it more interesting. To do that, we switch to the rotation tool. Notice how all of the different tools are up.
Okay, here's the thing. Make him go up. Oh, it's on. That's why. Up, and then I will. I play it now. Fall MF. Why the heck it isn't falling now? It, oh, oh wow, 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 wow.
Here. Right now we have the move tool selected. We can also shift to rotation scale, and then this one is for manipulating 2D graphics, which allows you to easily do all of the different things at the same time. You can always switch between these really quickly by using Q, W, E, R, and T. So we're going to press E to rotate, and I'm just going to kind of rotate it in a random advanced physics applied than we were able to see before. So I'm just going to undo that rotation by pressing Ctrl Z, and I'm also going to move him down here. We can also try duplicating him, so let's press Ctrl D to duplicate, and let's move this one up and over a bit and see how they interact with each other. Awesome. So one really important thing to understand is what is making these objects behave this way. And the answer is of course components. So if we now exit out of play mode and select the player here, we can see that he has all of these different components. The first one is something that you will see on all game objects called a transform component, which just keeps track of where the game object is in space, how it's rotated, and its size. You can see we can adjust all of these and the game object will be adjusted accordingly. And also, if we go ahead and drag on the game object, you will see the transform component updating. The rest of them though are all optional. We have the mesh renderer down here, which is responsible for drawing the object on the screen. If we go ahead and disable that, it's actually going to disappear. It's still in here, you can see it's still in the hierarchy and it still has this green box and we can move it around, but until we re-enable the mesh renderer, it's not going to be visible. Then of course we have the box collider. Without this, we wouldn't be able to collide with other objects. If I go ahead and disable the box collider and then hit play, this should just fall through the ground. But if we then go ahead and re-enable the box collider, you can see that it's now able to collide with everything. So remember, to get realistic physics, we both need a collider and a rigid body, and in order to see it, we need a mesh renderer. I of course skipped the mesh filter up here. That's not because it's super advanced, it's just that this is only responsible for a very simple thing, and that is choosing the shape of our object. Right now you can see it has the cube selected. We can easily go in here and change it, so we simply click on the little ball here, and we can change it to a capsule, a cylinder, a plane, a sphere, and so on. And you will notice that it's distorted, but that's just because we messed around with the scale. So we can just change that to 1, and you will notice now that it's a sphere. Of course, our box collider is still a box. So if we want this to behave like a sphere, we'll need to remove the box collider. So right click, go remove component, and instead add a sphere collider. And notice how I'm just using search here. That just makes things a lot easier. So let's just enter that. And you can see now that it has a sphere collider, so if we go ahead and hit play, it acts like a sphere. And this is of course more noticeable if we move it over so that we can see it hitting the box. And it's going to go and roll off our ground plane. Another thing is you can also adjust values while playing. We could...
Okay, so what did it tell us? First of all, transform is the place. Yeah, you guys saw it. You guys heard it. Transform is the place like where the thing is. Scale is what's the size is. And mass filter is just a mass filter. Mesh render is make the object visible. What we can do, you know what? We can make it as an invisible wall, you know? We will we will make it as an invisible wall. Yes. Locks collider. Okay. Completely reset. Layer. Go up. Okay, I'll just type it here one. Done. And the rigid part is the physics. And this is the color. And the Q filter. Can make it capsule, cylinder, plane, sphere, chord, sphere, rigid body, sphere, mesh filter, mesh render, duplicate it, make it go up, and the bottom thing will be cube. Make it go here a bit and up a bit, then boom. Why didn't it roll? Go a bit here, go up, and render, and then oh, oh fuck. Rigid body. How the heck did he change that? Box collider, mesh render, player mat. He changed it to physics, sphere. Okay, wait, let's duplicate this. It behave like. What about this? Hey, this is fun. Boom, 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 boom. Yeah, and fuck. Yeah, yeah, go, go that way. Go, go, motherfucker. Kill him. It behaved like a sphere, but it didn't fall that way. Never mind, something might happen.
Could take our player here and we
Just delete it. This is our player. This is cube, mesh render, box collider, rigid body.
we're
Okay.
still playing and move him around. It might be a bit buggy sometimes when using the physics system, but we are able to do it. We can even go in here and say disable the ground plane or do different stuff like that. But just know that any adjustment that you make while in the game and running are going to go back as soon as you quit playing. So make sure not to do any important adjustments while playing, or at least remember your settings, or else you're just going to have lost progress. So the final thing I wanted to do is just delete the ball here and maybe make this a bit prettier by changing our skybox. To do that, we go and select our main camera, and as the skybox here, we're going to change it to solid color. And let's make the color here a very white gray. Not the most exciting thing in the world, but I think it looks pretty simplistic and cool. By the way, the
A lot of things changed, bro. Skybox, solid color. Let me pick it, MF. Okay, so we will make it this. Yeah, this one.
The way I just maximize the game view here is something you're going to see me do a lot of times. That's by hitting Shift Space. Finally, to save your game, we can go ahead and hit Control S.
This. Oh,
Or Command S if you're on the Mac, or go to File, Save
save as, save as, save as, save as.
Scenes, Then we need to name our scene something, and scenes in Unity are basically just levels. So we'll just go ahead and call this one level 1. And hit save. You can see now that the scene appears down here in the project panel. If we had multiple scenes, we would be able to shift between them by simply double clicking to load that
File, save, file.
level up. And we are to finally to save scenes. Then we need S or Command S if you're on the Mac, or go to File, Save.
I think I don't have save things option. New scene, open scene, condition scene. I guess this is it. Unity. Create one folder. Unity. Save. What? Okay. This is saving somewhere. I'm gonna start. Okay, I guess this is saving user. What is the name of this widget? Start. So this I guess will relate all set. Start. This it. Shit. Things. Sample scenes. It's the scene I guess. That's it. Oh no, yeah, that's the project. Start. It's already saved.
Scenes. Then we need to name our scene something, and scenes in Unity are basically just levels. The scene appears down here, things are itself. The subscribe button to be notified when
Okay. Unity is kind of updated, so it did a lot of things by himself. Okay. But alone this one. Okay.
Today we'll get
first
started
go.
programming in Unity. I did a poll asking what language you guys would like to see, and the results were, well, Conclusive. So today we'll be creating our first script. We'll have a look at how you can change properties and even add forces to an object. So I'm really excited. Let's just jump right into it. So whenever we want to program in Unity, we create what is called a script. To do this, we click on the object that we wanted to sit on, in our case the player, and we hit add component. Then we go down here, select new script, and we can give a name to our script. In our case, it's going to be something like player movement, but you can really choose anything you'd like. And we select the language. In our case, that's going to be C#. So create an add, and you can see that Unity adds a new component. And that's because scripts in Unity are pretty much just custom components that we get to tell what to do. It's also created a script file down here in the project panel, and that means that we can add it to other objects as well. So if we now select our ground, we can drag our player movement onto that in order to make it affect the ground as well. But we don't want to do that, so let's just right click on it and hit remove component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using, or Mono Develop, which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it. There's a lot of scary stuff going on here. The thing about learning to program is that at first you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go ahead and delete the two using tags up here. And really the only thing that you should focus on right now is these two functions, where it says void start and void update, and these are created by Unity automatically. So let's have a look at the start function up here. The neat thing about the start function is that it will run when your game starts. That means that whatever code you put between this curly bracket and this curly bracket, so that means in here, is going to be executed when you start the game. Do note that in C#, it doesn't matter how many spaces you have. You can really space it out any way you want. You can even put it on separate lines as long as you don't split up a word like this. Let's just try and see if this is working by displaying a message to ourselves. To do that, we write debug.log and make sure to have capital letters the same places that I do, because C# is cap sensitive. Then we open up a parentheses and you can see that it automatically closes one as well. Then in quotation marks we get to write a message. In our case, we'll just write something like hello world. Make sure you end this line with a semicolon. You're going to be doing that a lot. Whenever you write a command, you're going to end it with a semicolon. If we now save this by hitting Control S, you can see that it saves up here. Head back into Unity and hit play. Nothing is really going to happen in our game view. However, if we go ahead and look at the console here, you can see see that it now says hello world. If you don't already have the console open, you can go window and then console. So the console here is used by us to debug our code. It allows us to write messages by using debug.log followed by our message, and it also displays warnings and errors about the code that we write. So we really have a love-hate relationship to the console. If something isn't working in your game, make sure to check the console and see if there's any errors or warnings. They might help you troubleshoot the problem. Alright, so writing hello world in the console is a bit boring. Let's have a look at what else we can do. Well, in fact, we can do pretty much anything in Unity. We can modify values, we can add forces to objects, we can add explosions, create game timers and menus. The possibilities are pretty much endless. And that's also kind of what makes programming scary, is that you have a lot of functionality available to you. But let's try and focus on a specific problem. So let's say that we want to go into our rigid body and disable gravity for that object. To do that, we need first of all to reference this rigid body component. And Unity makes that really easy. If we go into our script and go above our functions on this empty space here, create some new lines, and then write public, then the name of our component is called rigid body, then the name of the component that we want to modify, in our case rigid body, and now we need to give this reference a name that we'll use internally, so we can call it something like RB for rigid body. If we save that and hit back into Unity, we should now see an empty slot here with the name of RB. We can then take our rigid body and drag it into that slot. So now whenever we write RB in our script, it's going to refer to this particular rigid body. That means that if we go back into Visual Studio and instead of writing debug.log here, write something like rb.useGravity, we can set that equal to either true or false. In our case, we're going to set it to false and then of course end with a semicolon. So save that, let's hit in a Unity, and let's see if this value isn't going to change when we hit play. So let's hit play, and indeed the used gravity changes to false. We can see that our
It works very well.
false. In our case, we're going to set it to false and then of course end with a semicolon. We hit play, so let's hit play, and indeed the used gravity changes to false. We can see that our cube here, just how cool of an effect. And if we were to duplicate him so that the two would collide, you can see just how cool of an effect that already gives us. But this is just editing a tiny little property. We can also make our rigid body do different things. If we quit playing, go back into Visual Studio, we can actually add a force to that rigid body. So instead of writing rb.useGravity, let's write rb.addForce. And again, we open a parentheses, close a parentheses, and then end with a semicolon. However, you can currently see that this is displaying red. And the reason why is that we need to specify a few things. These are called function arguments. The addForce method wants to know how much force it should add in the different directions. So we could start with 0 on the x-axis, we could do something like 200 on the y, and maybe 500 on the z. Notice how I separate each number with a comma. We can then hit save, go back into Unity, and when we now play, we should see a force being applied to this object. Awesome. So let's stop playing, head back into Visual Studio. And what we want to do is not only add a force in the beginning of the game, we want to add a constant force in order to move our object forward. To do that, we can't use the start method. Remember, this is only called once right when we start the game. However, our update function is called once per frame. That means that whenever the computer draws a new image, and it does this multiple times a second, this function is going to run. So let's again put this on a new line to make things a bit easier to see. And we can then write rb.addForce, just like we did up here. We can input 0 on the x, 0 on the y, and let's try 200 on the z. Again, remember to close it with a semicolon. Let's also take our entire start function up here and remove it. So now we hit save, go back into Unity, hit play, and we should see our cube just launching into the distance. And indeed we do. However, even though our game currently runs just fine and we get no errors in the console, we do actually have an error in our code. If we stop playing, head back into Visual Studio, we can see that everything looks just fine. But there's one problem. And that is, if this method is called once per frame and we add a fixed amount of force each frame, how much force we add over a second is actually going to totally depend on our frame rate. And that means if you have a really good computer that is drawing a bunch of frames a second, the cube is going to travel faster than on a slower computer that doesn't run as many frames per second. And the frame rate can even vary on the same computer. If a bunch of stuff is going on the screen, the computer usually slows down a bit in order to handle everything. Or if something is happening in the background, that might also change your frame rate. So in order to even out these differences, what we do is we multiply this value, the 200 here, with what is called time.delta time. This is a bit confusing, but basically what time.delta time is the amount of seconds since the computer drew the last frame. So if the update is running 10 times a second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.05. So the higher the frame rate, the lower this value is going to get. And therefore it's going to even out the advantage that you would get if you were running on a good computer. If you don't get this right away, that's totally understandable. I sure didn't the first time, just right after me for now. So if we now save this and go back into Unity, we should actually see a pretty big difference. And that is, our cube is not moving now at all. And that's because on my system, it's drawing a lot of frames, and so overall the value gets a lot smaller than it was before. The workaround for this is super simple. We just need to go into our script and make this value bigger. I'm just going to add another 0. Save that, go into Unity, hit play, and we We should see him just storming off here. It doesn't look like much of a difference, but now we can at least know that it looks the same way on all systems. The final thing we're going to do is yet another one of those it doesn't look like it's wrong, but it's actually a little wrong kind of things. And that is that Unity really likes it if we use what is called fixed update instead of update for calculating physics. And in our case, we are using the Unity physics system. So just make sure that whenever you do physics stuff, if you're adding forces or changing velocity, do it inside of the fixed update. Unity likes that a lot better, and it's going to make everything look a lot smoother when you collide with stuff. Also, if you find all of this confusing, I totally get it. One thing that you can do is use the fact that we can make comments inside of our code. So you can see this line here is grayed out. That's because it's marked with these two slashes included in your code. And so it allows you to say this at the end of a line. Also, I see a lot of beginners using spaces to indent their code. I find it a lot easier to just use tab, but it's something programmers have argued about for decades. So let's just save our code a final time and enjoy the result. Until the next video, you can of course play around with this by adding more objects into the game. Let's add another cube here, for example. And this already has a box collider, so it should actually collide. That's pretty much it for this video.
Oh, oh God. Mm, now this was a great jump. Look at this. You, you, boom, and then out of the field, sixer. Okay, so we are here. Oh my God. We know how to add a platform, to use gravity, we know how to use colors, we know how to use all the objects, we knows how to move them, we knows how to collide them, we knows how to mess with the gravity inside VS Code and code. Actually, I'm learning coding, so I can understand a bit, and I will be able to understand. This is a header file, and I guess this is the variable, and no, wait, this is the variable. Added a variable rigid body which is called RB, and then here's the function called fixUpdate function, and we added force. We added this much force to rigid body and multiplied it with delta time. I don't know what is delta time and some of thing, but I can understand code because I'm learning. And I'm a currently computer science student. Oh, second semester, first year. So yes, I'm learning coding too. So it will be not easy, but yeah, I can understand coding because I have to learn coding uh, like a self. So that's why. And I guess this is the next video. Let's play the next video.
Hello
Episode
everyone,
3.
in this video we'll make our player move. To do that we'll have a look at variables, if statements and player input. So if you want to make games in Unity, this video is pretty much essential. I'm ready, are you ready? Let's go.
Yes.
Before we get started I just
Oh, yes, let's
want
go.
to mention that you can now download the project files and the scripts from each video over at DevAssets. So if we go to devassets.com, this is a website I created where you can download really high quality 3D models such as this Western props pack. We have a modern weapons bundle, some cool looking sci-fi vehicles and a lot more. If we go to browse, scroll down to the bottom here and click how to make a game, we get to this page where you can download all of this stuff. I've seen a lot of tutorial makers make their project files paid, but I don't really think that's fair to you guys. Instead, as with everything on the site here, I've made it pay what you want, so you can of course go ahead and grab it for free or choose to support me with some amount. You can just
What?
click the one that you can afford here and then hit the blue button and you're good to go. So back to the video. In the last one we made our cube fly forward by adding a force. Right now our primary issue with this is that our player doesn't stay on the ground, he just starts rotating and jumping and goes crazy. One way to fix this is to go to the player, find the rigid body and add some constraints. We could for example freeze the rotation on the x-axis and that should result in smooth movement. However, we do want our cube to be able to rotate so that when he collides with something, it's going to look cool. So let's uncheck that and instead let's create a physics material. The reason for the cube jumping around is that by default there's friction between the cube and the ground. By using a physics material we can choose how much friction we want. So let's right click in the project, go create and then select physics material. We can rename this to something like slippery and we can set
Okay, first let's remove this one. And then what the heck? Okay. Create and then physics material. Oh no.
both the dynamic
Slippery. Slippery. I forgot this. Whatever.
dynamic and the static friction to 0. Then we can drag this onto our ground and you can't see and the static material. We can rename this to something like slippery, and we can set both the dynamic and the static friction to 0. Then we can drag this onto our ground, and you can't see it being applied, but if we go ahead and select our ground, we can see that the material under the box collider is now set to slippery. And that means
so I want to make it 0 and then 0 and then remove the set. That actually look like a set. And add this to this and then make it ground. And then if we go to box collider, it's slippery, yes.
means that if we hit play now, there's no
My
friction
bad.
between the cube.
Let's see. There's no friction.
In the ground, and he's just going to slide off, and that's without restraining his rotation. So if we now select the player and double click on our player movement script, on this line we're adding a forward force of 2000 and then of course multiplied with time.delta time. However, it would be really neat if we were able to modify this value in the inspector instead of just hard coding this into the line. To do that, we use variables. In C# I like to think of variables like containers. Just like you can store items
So
in a box, you can store data in a variable. In the beginning, we focus on storing simple values like numbers or text, but variables can be used to store way more complicated data. Each variable is given a name. This pretty much just means slapping a label on the container so that each time we use that name, it refers to the data of the variable. We also have to specify what type of data we want to store. For starters, you should learn and memorize the 4 fundamental data types. Integer, we just write int. This stores a whole number. It can also be negative. Float, this stores a number with decimals. String, this stores a piece of text. And boolean, we just write bool, and this is the simplest of all the data types because it can only have 2 values, true or false. So creating a variable looks like this. Unity also allows us to edit a variable in the inspector. To do that, we mark it as public. However, this variable is currently unassigned. It has no value. We can assign the variable a default value by simply typing equals and then the value. To get the value of the variable in code, we simply write its name. Like here where we are printing the value 10 to the console. We can of course also edit the value of a variable. Here we set it equal to 5, and here we add 1 onto the current value, making it 6. So if we want to turn this number into a variable that we can edit in the inspector, we'll go up here and create some space. We'll write public, float because we want a number that we can fine tune with decimal places. Then we need a name. In our case, we could do something like forward force, and we can set a default value. In our case, we'll just set that to the same 2000. Then we can substitute this number with forward force. So we'll just take the forward force here and paste it down there. If we now save, go back into Unity, we can see that we are now able to adjust the forward force in the down there. If we now save,
looking open, bro.
उधर चैनल का नाम क्या है?
Net. Then where the fuck is my cursor? Or forward force equal to without enough sensors replace it with
मस्त स्टिकर ले ओ भाई मोबाइल थे एक नंबर
this.
डेट नोट ना बताओ ना मुंह दरवाजा वाले टाइम लो तू आई नहीं
1000. And then boom, make it very boom. And here you go. Boom. Fast, fast. 2000. And then um
Save, go back into Unity, we can see that we are now able to adjust the forward force in the inspector. We could set it to 4000 or to 1000. If you click and drag on it, you can even fine tune like this. And you can even edit it while playing. So now of course we need to change this comment here. Instead we'll change it to something like add a forward. Understand? We can write basic structure of an open and close a parenthesis and then open and close some curly brackets. This is the basic structure of an if statement. If statements allow you to only execute code if a certain condition is met. This is where you put your code, and inside of these two parentheses is where you put your condition. Sometimes it's really simple, say comparing two numbers. We could write if 3 is bigger than 2. Of course this is always going to be true, and so this will always be called. We can also say if 3 is equal to 2, and this is of course false, so this code will not be called. We can also write other stuff, say if 1 is equal to 2 minus 1, and this is of course true, or we could put not equal to, and now it's false. But this is only the stuff we can do with numbers. We can also put other stuff in here. If we want to check if the user is pressing a certain key on the keyboard, we'll go input.getKey, and here we'll also open and close a parenthesis, and in here, in quotation marks, we write the key we want. So in our case, we want D to go to the right, and now everything we put inside of these two curly brackets is only called when the user presses D. So we could of course just go ahead and add some more forces here. Let's say rb.addForce, and in this case we don't want to add a force on the z-axis, we want to do it on the x, meaning right and left. So we can go in here and add some numbers, say 500. We'll then do 0 on the y and 0 on the z. Remember to close it up with a semicolon. Of course we want to multiply our 500 with time.delta time, just like we do up here. If we now save this, I'll just set the forward force to something pretty low, just so our cube doesn't go flying off. We can hit play, and we should see that when we hold down D, our cube will indeed move. So we can go back and add this to the other direction as well. To do this, we simply copy our code, paste it right beneath. Instead of checking for the D key, we'll check for A. And we still want to add a force on the x-axis, but we want to do so in the opposite direction. So we'll just input a minus here. Again, we can save this, play the game, and see that we can now move in both directions. In fact, why don't we go ahead and make our movement speed adjustable in the inspector the same way we did with forward force. To do that,
So now put it to 1000 and run this. Now I can go left and right and left. Yay.
That we just add a new public float up here, and we'll call this something like sideways force. Let's just default that at the end of the number. This just signifies that we're talking about a float number. In some cases we can leave it out like here, but other times Unity will complain, so it's a good idea to get in the habit of just doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500 here and instead of the 500 here as well. You'll notice that it's still fine putting a minus here. When we run the game, this is just going to be equal to 500, or what we said in the inspector. So let's save this, go back and run the game, and instead of the 500, now to get in the habit of just
force and 500 5F. So do meter public float right raise force is equal to 500F. And now we got to copy this set and paste it here, paste it here, then paste it here, and then go to Unity and I got this sideways force. Make it very fast. Then make it slow. And what will happen if I go this and do this? It's yay, very fast. Oh, it falls. It falls, bro. It's still fun. I didn't even make it yet, and it's fun to play. Bro, fucking fell off. Fell off the fucking shit. Let's see. Okay, I will be right back. Oh, so where was we?
Doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500 here, and instead of this going to be equal, we can adjust the size to something like you're able to follow along with this really. And so it's you don't have player movement here is not the most efficient way, but no one expects you to write perfect code right off the bat. I just want to let you know how this could be improved. There's two main problems here. The first one is how we're getting player input. Now using input.getKey here is totally fine, and in our case it works perfectly, but as soon as we want to do stuff like smoothing player input, supporting alternative keys, or maybe even a controller, Unity has some much better ways to handle the player input, so you can definitely look into that if you want to improve it. Also, we are currently checking for input inside the fixed update. Well, it's fine in our case because what we're doing is movement, and that's usually a fairly smooth thing. It's definitely not a good idea to do for stuff like jumping or other one-off events. The reason for this is that input is updated in the update method, and if the fixed update runs slower, you might have a situation where you actually miss some player input. First, that would just mean that the input gets slightly delayed, and that's why I think it's fine here. But the recommended thing to do is check for input in the update method, then store that input in some sort of variable up here. In our case, that could just be two booleans called something like move right and move left that you'd set to true if the key is pressed and false if the key is released, and then check if those variables are true or false down here to add a force. But I really wouldn't worry too much about that right now. So that's pretty much it for this video. If you enjoyed it, make sure to subscribe so you won't miss.
Okay, so each time we have 130. How long? Okay, let's go for another.
In this video, we'll have a look at making our camera follow the movement of our player. Not really much to say about that, let's just jump into it. So as with everything else in game development, making the camera follow the player can be done in multiple ways. The first and most obvious one is probably just parenting the camera to the player. Unity allows us to nest game objects. That means that we can take our camera here selected and drag it under our player. We have now parented our main camera to our player, and the main camera is now a child of that player. This means that whenever we go and move our player, the camera is going to move with him. However, the problem with this is that if we go ahead and rotate our player, the camera also rotates with them. And that's going to look very weird when we collide with something and the cube starts spinning, then the camera is going to spin with it and everything's going to be confusing. So what we do instead is we take our camera and unparent it, and we make it follow only the position of our player using a script. So let's go and hit add component. We'll call it something like follow player. Select C# and hit create an add. Let's double click it to open it up in Visual Studio, and let's clean up the script a bit. So let's delete the two using tags up here, and let's also delete the start method. Now just like when we wanted to move our player, where we wanted to move him a tiny bit each frame, we also want to have our camera snap to the position of our player each frame. So we'll put our code inside of the update method. However, in order to set our camera's position to that of the player, we need a reference to the player. The easiest way to do this is by making a variable that stores the reference to our player. So when we create a variable, we write public, and so far we've only looked at the basic data types, stuff like float, integer, and string, that stores numbers and text. But variables can actually also store way more complicated stuff. If we go ahead and write transform here, we can basically get a link to our player with information about his position, rotation, and scale. Remember, the component responsible for these things are indeed called a transform. So that's what we're getting a reference to. Then of course we need to name it something, but we'll just name it player. Let's close that with a semicolon, and if we just try and hit save now and head back into Unity, we see that an empty slot called player now appears. All we need to do now to make this player variable point to our specific player is to take the player and drag him into that slot. So now every time we write player in our code, it refers to that object. To test this, we can go inside of our update and we can try displaying the position of our player in the console. To do that, we write debug.log to write a message to the console. Inside of the parentheses, we then write player.position and we close it off with a semicolon. Now every frame we should display a message in the console with the position of our player. Let's save that, head back into Unity and hit play, and if we go and select our console, we can now see that position updating. If we select our
So I do this going and console. It's updating. Okay, all fine. All good till now. Let's
our
see.
player, the two numbers should correspond. So we can see here that our player is currently falling, and so his Y value is rapidly decreasing, and it does the same thing in the console. We can also see that he's moving a bit forward on the Z. Again, he's also moving forward in the console. So now that we have this link between our script and the player, we can take the position of our player and feed it to the camera. So let's stop playing, head back into Visual Studio, and instead of writing the position of our player, we'll go transform, and whenever we write this with a non-capital T, it refers to the transform of our current object. That means the object that this script is sitting on. It also says so here, the transform attached to this game object. So by writing transform and then dot position, we're referring to the position of our camera because our follow player script is sitting on that object. And just like we were able to display a position, we can also set it equal to something else. So now we could move our camera anywhere in the world, but we want to move it to a very specific place, and that's the position of our player. So we'll set it equal to player.position. And again, we'll close this off with a semicolon. So now our camera's position, this game object's position,
What to do? What transform? What position? Equals double equals no single player dot position.
is going to be set equal to the player's position every frame. So let's save that, head back into Unity, and technically our code doesn't have any errors, but there's a main problem with this. Let's try zooming out in the scene view so we can see what's going on, and hitting play. We can see that indeed our camera is following the player, but it's following the center of our player. And that means that right when we start the game, our main camera snaps to be inside the player object. You can see that the effect here is that we're getting kind of a first
So go here, go like this. What isn't following? I didn't save the script. Saved it, and now it's following, but it's first person. That's the problem. Yep, okay. Next
first
one.
person view. Of course, this might be something that you want for your game, but in our case I think it would be better if we move our camera a bit back from the player and a tiny bit up. To do that, we'll create another variable. So again, we'll write public, and I'm going to introduce you to another data type. This one is called vector3. And a vector3 is actually really simple. All this does is store 3 numbers. A float stores 1 number with decimal places. A vector3 stores 3 floats. And that makes it really easy to use when it comes to positional data, because we have an X, a Y, and a Z. So if we go ahead and name this one offset, save it, and go into Unity, we should now be able to specify an offset on the X, Y, and Z value. So in our case, we want it to remain centered on the X. So we'll leave that at 0. But we do want it to lift it a bit on the Y here. So we'll set that to something like 1. And we definitely also want to pull it back. So we'll set the Z here to something like -5. So now that we have this offset on the different
Vector3 offset. Like vector3
We'll set the z here to something like -5. So now that we have this offset on the different axes, all we need to do is add it onto a player's position. So to do that, we'll go in here and say player.position and then plus offset. And we are very used to seeing the plus here being used between two numbers, but unless you have experience with college level math, you probably haven't seen it between two vectors. How do we add three numbers onto other three numbers? It's kind of weird. If you want to learn more about what's going on here, I have a video on vectors that you should definitely check out. Basically what's happening is we're taking the x position of a player, which is currently 0, and we're adding 0 onto that, so that's still 0. Then we're taking the y, which is 1.16 in this case, and we're adding 1 onto that. And then finally on our z, this is currently 0 as well, and we're adding -5 onto that, so that's -5 on the z. And we keep doing that as the player moves forward. So in this case, our x would still be 0, our y would be 1.16 plus 1, which is 2.16, and our z would be this number minus 5, which is equal to 1.63. So make sure you save your script and hit play, and our camera should now follow our player.
Oh, it's working. Okay. So the main camera is -5 1, player 1, players increasing, main camera. Okay, good, good.
With a nice offset position. And this is much better than parenting, because if we tilt off the ground here, you can see the cube rotating, but the camera staying in place. So that was pretty much it for this video.
Okay, got it. I have an idea. I'll do something on my own. But I guess good for today. Hmm. Mm, we are on episode 4. I will do it by myself. Listen, I got the idea what it's going to do. I will do it by myself, but maybe I can watch the video. But now, good. Control save. Where is the file? Here, 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 and then and put here. This is all the files. Okay, good, very good. And then I will do this. Let's do something on this. I will increase the size of this. Let's move this. Let's move it to 1000. Let's move it like here. Then control save, then play. And I will have turtle. Nice. Oh, fuck. Let's fall. It just fall. You're moving. Yay. Oh, never mind. You're falling. Okay, this is it for today, I guess. Let's pause it, save it. And now I guess let me explain what is this. I know some of this, but not all the things. We're using Unity. This is header, forget this. All player, let's focus it here. Public. Public is just the data type. This is the variable. Transform is a variable, and this player is the name of a variable. Okay, so we identify like well, this to this. Okay, and then vector 3 is main cameras, this one, and then this one. So we got the offset here. Now what we've been doing, mode update, and we are transform position, like position of this main camera's transform, and then player's position. So we have the position of this and this. Whenever the player of transform position, that means the position of main camera will be equal to player's position plus offset. So, so the in simple words, so the position of camera will be equal to the player's position and the offset position. So the offset position plus the player's position will be the position of the camera. You understood? So before, what was happening, if we are like keeping like main camera under the player, it will be baby, something like that. So what that happens, it got on FPS mode, first person mode. So that doesn't look good. Then what we did, we made into like an offset and a player. So what we did, we made offset and a player. We track the position of player, and then we track the position of no, we just track the position of player. And then what we did, we added an offset of y1 and z minus 5. So the position of camera will be equal to the player's position plus this. So minus 5 will be a back. So from a little bit back, and the position of the camera, no, it's the position of the player plus that. So it will be little back from the back. So camera will be always the little back. It will always follow the player, but from back. So yeah, I hope you get it. I'm really not a good teacher, but I will try some, because if I try to teach you, I will learn by myself. So I guess that's for today, and we will meet tomorrow, I guess. So we're on episode 4. We will watch episode 5. So see ya.